Hi, I'm Brennan. This is my channel where I share with you the creative journey I'm on, and this is a creative outlet for me to kind of explore some ideas and thoughts that I have. So today we're to continue our conversation about size scale in GURPS. So GURPS is the generic universal role-playing system, and it is my favorite role-playing system because I can express almost anything I want in it. I don't need to invent a whole new character class, or I can go ahead. I don't have to wait for a monster to be published in a monster manual. I can make all of that myself using GURPS, just its basic rules. So my goal is to look at opportunities to revise how GURPS 4th edition works a little bit, to make it even more generic and universal and more easily applicable, just to kind of bring its level of complexity down a little bit. So first I need to make a small correction on what I did last time, and a little bit more math that I did. So here are some computations I did. We're looking at size modifier, looking at the weight, how that you apply the weight factor to a creature. This is the cube law growth. It's actually, the way it's written out here is actually the exponential, or not exponential, but logarithmic. And the weight increases basically with the cube compared to the length of the creature represented by that size modifier. So if your creature that's twice as tall as a human, so say 12 feet tall, that's a size modifier of +2. If it's 5 times as tall, a size modifier of +4. Using the GURPS fantasy book, you can determine the weight factor. It follows a sort of 1, 3.2, 10, or the 10, 32, 100, right? So it's a 1, 3.2, 10 pattern. And then the length factor associated with the size modifier follows this 1, 1.5, 2, 3, 5, 7, 10 pattern. And the strength score, according to GURPS Fantasy, is you take your weight factor, and your strength factor is going to be the cube of your weight factor, which I said that's basically just your length, your length factor. And indeed it is. We can prove it here. So so this here is size modifier of 0, right? It's just 1 across the board. Your strength factor based on the GURPS fantasy scaling will be 1.47. Your length factor is 1.5. So those are pretty close. For size modifier +2, length factor is double. The strength factor is 2.15. And then 3, 3, 5, 4.6, round up to 5. 7, 6.84, same thing, round up to 7. 10 is the same. In fact, every 10, they're always identical, even when you go to smaller size modifier. Anyway, but overall, the same general rule of the scaling applies. So, here it's like 14.7, 15, 21.54, very close to 20, 31.75, round down to 30. It's the same sort of story across the board. Let's just underline at every multiple of 10 in our length factor here. Okay. So this strength factor, you don't need this column at all, actually, because you can really just pull it back to your length factor that's already in the basic set. So don't need the strength factor at all. As for the last time I looked at armor and weapons, there's a little bit of going on of comparing apples to oranges, where I was looking at the length modifier compared to the strength, compared to the weight. Overall, those numbers still come in looking fine. In fact, they're a simpler system than having to convert to strength and convert back, and the messiness inherent in that. But I went ahead and did that calculation here anyway to figure out what kind of the typical strength of a giant or a miniature person of similar proportions to a human, what that strength would be. And the reason why I did that is because I wanted to look at damage. And something I didn't do last time is take a look at how weapons scale based on the typical strength. I mean, strength was part of it, but I want to transform that into the creature's size using this relationship between their size modifier and their strength. The first thing I did actually was, if I remember this graph from last time, I stripped a lot of it out of it. So today I really just want to talk about the damage modifier. So I took all the other series out of this graph. And I did apply others like nonlinear fits to this. The linear really was the most straightforward and best fit one if you just go by the R² value. Again, I'm just using Microsoft Excel's trend fitting algorithm here, so nothing fancy. What I did here is I chose normalized strength, which is what would the strength be to use that weapon, to use it one-handed and have it not be unready after an attack. So for a balanced two-handed weapon, this is twice its listed strength value. So you're using two-handed, two hands, two hands to wield this feather. Instead of looking at that and comparing two-handed weapons to one-handed weapons, I said, let's just look at that two-handed weapon. How much strength would it take to wield it as a one-handed weapon? So that's how we get up into these really high values up here. So for a balanced weapon, wielding a great sword in one hand without it becoming unready after you attack requires twice the strength. A unbalanced weapon like a great maul, like a maul, or a halberd, requires 3 times the listed strength to use it one-handed without it becoming unready. That's how we came up with these numbers here. So I normalized the strength values. Now we can look at damage modifier, and the first thing I want to notice here is that it actually follows a curve a little bit more like this, which I thought was kind of interesting, with a lot of growth early on, and then it sort of levels out later on. So this is kind of a first look at that. I just want to normalize that and see what that curve looked like from this perspective. But then I wanted to transform it, like I said, using these relationships. Transform that into what size creature would typically be able to use that weapon one-handed. And I'm looking at the average creature here. So I'm not looking at a burly or strong creature to use that weapon. I'm just looking at what size of creature would typically be able to use it on average. So some weapons, like an axe in GURPS, requires 11 strength. Well, 11 is more than 10, so you'd have to be a size modifier. So it would be a size modifier +1 creature to be able to use that axe. Make sense? I hope that does. So in here, the linear relationship becomes much stronger. And something that I find interesting here is that we go from 0 at size modifier -1 to +1 at size modifier 0, and that seems to be true. Most weapons requiring strength 6 to 10 give you a +1 modifier. And then it goes up to this +2 region between size modifier +1 and 2. So this is where you would get your damage +2 on that weapon. And then it'd go up to +3 at size modifier 3, +4 at size modifier 4. It has this growth rate of 0.7. Fairly linear relationship with a creature's size modifier. So instead of using the damage scaling that's in the low-tech companion 2, what if we just used this scaling and then you round to the nearest, whether that's up or down? I don't know if it really matters here. I would probably, for this case, I would probably round these both. Well, if you round it down, I suppose you could keep this to 1, 1, 3. Yeah. Let's say 1, 1, 2, 3, 4. So since this is already, right, so already +1 on most weapons, so this would mean that here you're going to add You're actually not going to add anything for size modifier plus 1. You'd add 0. Good. Then we're going to round down to the nearest. Here we're going to round down to 2, which is 2 is more than 1. So here we add plus 1. Here it'd be add plus 2. Here it would be not quite add plus 4. But you'd round it down, so this would be add plus 3. And then you could carry this on. You could either use this equation, or we could just say add plus 1, ... add plus 1 for each additional size modifier. We don't need to worry about that level of complexity. Or what I might actually recommend is do it even simpler and just use your size modifier. Say, if you have a weapon scaled up, like a short sword scaled up for a size modifier for a creature, just add 4 to the damage. So you just add the size modifier to the damage. Is it super realistic? No, but none of this is super realistic. Damage is already a very abstracted thing. If you try to calculate damage from like physics, you'll very quickly realize that it doesn't make a lot of sense. It's very hard to do that physical calculation in a tabletop pen and paper game. But we can get kind of close to this general idea just by applying the size modifier, or apply the size modifier minus 1 if it's greater than 0, or for if it's less than 0, you just straight up apply the size modifier down here. So this would be add minus 1. If we carried this down linearly, right, we'd end up near the minus 1, so this would be add minus 2. Yeah, so just use the size modifier. There you go. Okay, so that's my proposal for damage modifiers, to revise damage modifiers for scaling up weapons. Anyway, that's it. Thanks for being here. Thanks for joining me on my creative journey. Hope yours is going well. Let me know how it's going down in the comments, and we'll catch you next time. Thanks. Bye.